Coming up on this edition of The Climate Show, one of the leading experts on how climate change is affecting Greenland. His name is Jason Box, and he joins us just before he heads up to the ice sheet for another season. Also, we debunk some of the biggest myths around ice. We do that with John Cook from Skeptical Science. And a Porsche, an electric Porsche. All that and more coming up next. This episode of The Climate Show is brought to you by celsius.co.nz, hottopic.co.nz, skepticalscience.com, and Kiwi FM.
What good is a drop in the ocean? What good is a drop in the ocean?
All right, hello and welcome along to Climate Show, The Climate Show, episode number 7. It is recording this February 16th. I'm Glenn Williams, recording from the Kiwi FM studios. Joining me in North Canterbury, it is Gareth Ronalden. Hello to you, Gareth.
Hi, Glenn. How are you doing?
Very well, thanks. Very well. Of course, this show, it's all about climate change, climate news, science, policy, politics, and we even put in some solutions in at the end as well. We've got a fantastic show lined up, Gareth.
Yeah, I always end up saying I'm excited by what's coming up, but there are two reasons for that. The first is that I don't know how it's going to turn out, so that's exciting.
Yeah.
I always, so edge of the seat stuff. It's one of the nice things about doing these things live. And the second is that we've got one of the world's leading experts on Greenland, if not the world expert on Greenland, Professor Jason Box, joining us from California for our feature interview, and I'm really looking forward to that. Jason's an interesting guy. He knows more about Greenland than virtually anyone. He's about to go off on the start of the field season to go up to the top of Greenland to the Petermann Glacier and hopefully get some pictures of last year's big ice carving event. So it'll be fantastic and fascinating to talk to Jason. And there's actually been, just in the 2 weeks since we last recorded, a lot of developments that we need to run through.
Yeah, and it's funny, in that 2 weeks between our recordings, I'm constantly finding news and going, we make sure we include that, and by the end of the 2 weeks is over, we've got the stack of stuff to include in the show, and some of it, obviously, we do have to whittle out, but hopefully we're targeting the stuff that is probably the most important to concentrate on at the moment, but it's so far wide ranging, it's really hard.
Yeah, absolutely. There is such a lot of material just in terms of new scientific papers coming out.
Yeah.
Let alone world events, whether it be more flooding in Sri Lanka or droughts in the Amazon. All of these things are happening in real time, and they have a climate angle that we need to examine. Yeah,
indeed.
So shall we crack on then?
Yeah, and before we get into the news, I'll let you know also that John Cook is along, and of course he's going to be debunking some skeptical arguments. So we're looking at Himalaya Gate, and also we're going to be looking at popular ice myths as well. But first up, yes, let's have a look at some of that news, Gareth. First of all, some local New Zealand news. There was a report in the Herald, and I'm not so sure about the facts, and I guess you'll be able to go through it for me, but New Zealand has been baking in the hottest month ever. I know that's a bit of a headline grabber, but how real is that?
Well, we're about halfway through the month, and I think that that one of the interesting things we've talked about El Nino and La Nina and the Southern Oscillation in previous shows, particularly with reference to the Queensland floods, because La Nina causes the build-up of hot water off the coasts of Australia that then brings that sort of flooding rain. What it does for New Zealand is it tends to push warm subtropical air down over the north of the country. La Nina is a warm time for New Zealand, particularly the northern half of the country. It can also be quite wet up north too. And that's what's been happening over the first few weeks of February. The north of the country has been running at sort of 2 to 3 degrees Celsius warmer than normal. It hasn't been happening down here. We've had some warm weather down here. We had some remarkably hot temperatures over the Waitangi weekend. On the Monday, there was the warm air from Australia was heading across the Tasman, bumping into the west coast of the South Island and descending on the east coast and warming up as it did so. And Timaru Airport got to, I think, 41.3 degrees Celsius. 41.3 degrees Celsius, only a smidgen lower than the hottest day ever, which was in my little neighboring town of Rangiora in 1973. So, it's been hot, but particularly hot and muggy up north. And I think the departures from average have been large enough that even if the second 2 weeks of the month are normal or slightly below normal, that it will still end up being a warm month. But, these things, we really don't know. What is happening in the Pacific, however, is that just the beginnings of the hints of a sign that the La Nina event may be coming to an end. La Ninas often end in the southern hemisphere autumn or northern hemisphere spring. And so the big question at the moment is how soon will it come to an end, and what happens thereafter? It could be that and most of the models that do El Nino predictions are currently suggesting that the ENSO oscillation will be effectively neutral for most of the rest of this year. So there won't be an El Nino and there won't be a La Nina, it'll just be kind of neutral. But there is the possibility, a couple of models are suggesting that we could go back into an El Nino, which is the inverse of a La Nina, by the end of the year. So at the moment, the odds are probably on La Nina coming to a close in the next few months, and then neutral conditions through the New Zealand winter, Northern Hemisphere summer. One interest from the Northern Hemisphere perspective is that if we were to transition into an El Nino over the course of summer, as I say, only 2 models out of 20 or so are suggesting that might happen. That has an impact on the hurricane season in the North Atlantic because El Ninos tend to suppress hurricanes. So an El Nino could kind of prevent a bad hurricane season by, technically it's because it increases the wind shear over the Caribbean, which kind of knocks the top off the thunderstorms that provide the energy for hurricanes. So I guess there are a lot of people in the States who'd quite like to see an El Nino by summer. For New Zealand, El Ninos tend to be relatively cool and quite often dry. So it's funny that we talk about La Nina being the cold event of the ENSO cycle, but the effects in New Zealand are the reverse of what you might expect. But yeah, it's an interesting story, and I'll put if people want to find out what's happening to the weather up here in Waipara, I'll put a link on the show notes because I've spent the last few days installing a weather station.
Oh, cool.
Yeah, absolutely. I can tell you that it's currently 21 degrees out in my truffles. And the soil moisture's falling, so I'll have to put the irrigation on.
Oh, very nice, very nice. Well, it was certainly we'll look back at February in either the next or following episode and find out whether or not, in fact, it was the hottest month ever in New Zealand, or whether or not that was just a headline grabber. So, from New Zealand baking in its hottest month to the Amazon suffering yet another drought, Gareth.
Yes, and it appears that the Amazon had a drought in 2010 that was even more severe than the 2005 drought, and that was a 1 in 100 year event. And the really concerning thing about this is that, well, first of all, that you're having 2 exceptional droughts so close together. Now that might still just be a piece of bad luck, but what these droughts do in the rainforest is that they kill trees. Doesn't matter how wet it is after the drought is over, the drought itself has killed a lot of the trees that exist in the rainforest. And the 2005 drought killed billions of trees, and the 2010 will have killed even more. And this new paper by Simon Lewis of Leeds University and Paulo Brando of Brazil's Amazon Environmental Research Institute suggests that the Amazon forest will not absorb, because they normally, in the course of growing, absorb 1.5 billion tons of CO2 a year, which helps to slow down the warming, or the accumulation of CO2 from our fuel use in the atmosphere. So that, if we lose that slowing down, it's making the whole sort of the rate of warming likely to increase. And of course, it takes the forest a long time to recover from a dramatic event like that, where you lose billions of trees. Those trees have got to regrow. So it's not just human beings chopping down the Amazon, it's the change in the climate. And the climate models do show that the Amazon is likely to become prone to more and longer droughts. The really worrying thing is it looks as though we're beginning to see these things happening now. So this is another one of those climate events that we have expected, that we may have thought was some way off in the future, but actually it looks as though, oh dear, they're beginning to happen now.
But also, when we talk about drought in the Amazon, are we talking about the sort of drought that we see, say, in Australia with baked ground, or are we just seeing a slight reduction in rainfall, which to the Amazon is like a drought?
Yeah, obviously the vulnerability is different because the ecosystems in the Amazon it's a rainforest, it's a wet place, and so the systems are designed for ample water. You take that water away and you immediately have a problem. The trees themselves can survive for some time because obviously their roots go down into what hopefully has got a water table. Yeah. But again, they're not specifically designed to withstand drought. Whereas in Australia, particularly the trees are designed to be able to stand drought and fire and can last. Some of the Australian eucalypts actually require fire to make their seed germinate. So those things are long-standing, well-established ability to cope with what the climate is throwing at them. The rainforests are possibly less robust, but I'll point everyone to read the blog that my partner Brian Walker at Hot Topic did on this last week. It's good coverage. It links to the original papers, and it's an important subject that I think we need to keep watching, as with so many of the things in the climate issue we need to keep an eye on.
Absolutely, yeah. Well, we're staying with another story about drought. This time in China, where they're reporting a severe, long-lasting drought in the key wheat-producing eastern province of Shandong. And in fact, they've only had about 12 millimeters of rain since September, and there is no rain in sight until mid-February, so around about now. But that drought has been quite devastating on those crops. Now, it being China, information from the officials there has been really slow to get out, because I don't know if it's a saving face sort of thing, but they don't want to report how desperate things are until the things have gone too far, I suppose. But my understanding is that China is broadly self-sufficient in wheat. And so if you've got a situation where their own farming is unable to produce the stocks of wheat that they require, then they obviously have to go onto the world market to buy the grain. And of course, the world market for wheat is very tight and has been since last summer, when the heat wave in Russia, I think it cost them about 40% of their wheat crop. And Russia actually banned exports for a while because it needed to build its own stocks. So wheat prices have been soaring. I'm not sure whether the Australian floods have had any impact in that area, but certainly we're looking at a situation where climate extremes are beginning to have a direct impact on food availability and food pricing. And you've got a couple of other examples, haven't you, Glenn? Yeah, absolutely. Not too far away, of course, is North Korea, which is showing also signs of food stress due to drought in that particular region as well. And this is starting to become a bit of a theme, I suppose, around the world, where these climate extremes are affecting countries that rely on a stable type of crop. I mean, another example is in Mexico as well, where they have experienced not so much a drought, but those storms that have been moving their way up North America have been affecting Mexico. The cold storms, and their corn crop has been drastically affected. Now, Mexico depend on corn. The Mexicans, in fact, consume about 90 kilograms of tortillas, corn tortillas, in a year. So almost every single meal is served with a corn tortilla. So you can imagine the rising prices of corn and what that is going to, or how that is going to affect the people of Mexico.
Yeah, absolutely. And you look at the situation in North Korea, for instance. Some of that has got to be down to you mentioned China and their reluctance to admit to problems sometimes. Well, in North Korea, obviously a major component is likely to be their political system and the way that they govern themselves, which will add to the problem. So yeah, the climate extremes certainly are having an impact on food production and food pricing, but it's a complex relationship, and it's layered on top of politics.
Yeah.
So you've got just today a report from the World Bank, and they've given a warning that the impact of the rising cost of food has put 44 million people pushed into poverty since last summer, just by the soaring commodity prices, and that food prices have risen by almost 30% in the last year, and we're within striking distance of the record levels reached during 2008. It's one of the key things, one of the most controversial things that's been said in the last couple of weeks is that food prices were one of the reasons why the kind of political unrest in the Middle East started going, and particularly in Tunisia. And so you've got a situation where changes in climate have begun to impact the pricing of food. The pricing of food has begun to impact political stability in some countries. And it is possible that climate change has had a contributing effect to the political instability in the Middle East. So let's be quite clear about this. I'm not saying that Hosni Mubarak was deposed because there aren't enough tortillas for, not enough tortillas for the Egyptians, but this is the climate change is having impacts. Those impacts will interact with our societies in all sorts of complex ways, and maybe we are seeing signs of that in the political instability in the Middle East. So it's
well, it makes sense, doesn't it? I mean, we can talk about civil rights as much as we want until the cows come home. But if you're hungry, that is always going to be your top motivator for whatever you do. If you can't feed your family, it's always going to be the top motivator.
Absolutely, and of course, in countries, as you said right at the beginning, where people just depend on staple crops, or where they have a large reliance on a relatively narrow range of crops, or where they don't have much money, so they can't buy crops in from overseas, or where the prices are so high that they can't afford to buy as much as they used to. So you get a really complex relationship between food production in a sort of agricultural sense with the climate, with politics, with the economy, with the global interlinking of markets that helps us to be able to buy parmesan in New Zealand. But anyway, the blue graph that Glenn's put up on the screen now, this is the Food and Agriculture Organization's food price index, and it shows that actually at the beginning of 2011 that the real, which is the inflation adjusted index, has actually exceeded the 2008 peak now. So we're looking at a situation where food prices are currently ahead of anywhere they've been in the last 20 years, and this is having an impact.
Would it be fair to say that the food prices should have, just looking at the more in the last sort of 5 years, they also follow fuel prices as well?
Yeah, that's right. And there was a story yesterday, I think, on one of the New Zealand news channels about the increasing price of diesel and how that will feed through into our distribution and contribute to increasing food prices. The other side of that coin, of course, is that an ill wind blows someone some good, and international high food commodity prices is actually good news for New Zealand's exporters. So long as we're not being hit by floods and droughts and damaging events, our farmers are able to sell into a market where their goods are commanding higher prices. So, yeah, it's a complex situation. There are winners, there are losers. It just looks horrifyingly like there are far more losers than there are winners.
Indeed. All right, well, very shortly we'll bring on our guest for the show. It's Jason Box. He's a foremost expert on Greenland, and he's about to head back up to Greenland for the beginning of the season up there. But I do want to thank Scoop and Celsius, who have been very helpful in getting the show distributed and getting some awareness about the climate show out there. Of course, we've now got the website finally up and running. The climate show.
At last.
Finally did
And
it.
it's not blue though, Glenn. It's not blue. Last
No.
time I said it should. What have you done? You've gone grey on me.
I know, it just wasn't working for me, I tried blue on for a little bit, it was clashing. I don't know. But it's up there. Go and have a look, see if you fancy it. Make a comment if you like. Tell us what you think. And you can also go back and check out the previous shows there as well. But also thanks to scoop.co.nz for getting the show up on their site, as well as Celsius, celsias.co.nz as well. Thank you very much to those two. All right, here's the exciting part of the show. We've all been waiting for this particular section. This is when we bring on our special guest. In fact, today is one of the world's leading experts on Greenland and its ice sheet. His name is Jason Box. He's the Associate Professor at the Department of Geography at the Bird Polar Research Center at the Ohio State University in Columbus, Ohio. Currently, though, he's on sabbatical as a visiting professor at the University of California in Santa Cruz, and we're talking to him just a few weeks before he makes his first trip of the year to Greenland, which I'm sure he's looking forward to as well. Hello to you, Jason.
Hi, it's great to be here. I've enjoyed watching your show, so thanks for having me
Thanks
on.
very much, yeah.
Yeah, thanks for that, Jason. How's the surfing in Santa Cruz?
It's quite good. I surfed on New Year's Day, and it was easier than I thought it would be. I was standing up surfing, and so I guess you do some surfing down in New Zealand as well.
Absolutely, yeah. There's, I don't personally, but yes, it is a very popular pursuit.
Yeah.
Anyway, welcome to the show. Many thanks for finding the time to do this. Glenn and I have just been chatting about the impact or the potential impact of climate change on food supplies, and whether or not that's been seen in some of the unrest in the Middle East in recent weeks. What's your take on this issue?
Well, it's really no coincidence that there is unrest associated with food security, and given the observed increase in global temperatures, the associated drying of soil moisture, what we're observing is the higher frequency of droughts and heat waves. And so the Russian heat wave of last summer, the current heat wave in China, these are part of a pattern of climate warming. And now that global economic systems are interlinked, price spikes associated with drought, or the Australian drought in 2008, multiple examples of this type of impact on food security. And when it comes down to when people's food supply is threatened, that's when, in combination with other economic stresses, that results in people engaging in food riots. We have seen this. That was what actually sparked the overthrow of the Tunisian government. Was these were economic riots? These are people out in the streets, complaining to their governments. They can't feed their families. The price of a loaf of bread goes up 30%. They blame the government, and it's actually globally linked economic systems. A drought halfway around the world can affect the price of a baguette in France, and so it's just been striking me. I study cryosphere and ice, and and these unpopulated parts of the world. But when we see these types of very real, profound political problems, these are part of what climate change looks like.
Yeah, that's right. We kind of have a comfortable assumption that climate change is maybe going from the IPCC model curves, that it's going to be a smooth progression into the future, relatively gradual event that we can somehow adapt to as it goes, and yet we see in the extremes, the floods, the droughts, the impacts on agriculture, that it's not a smooth curve at all. It's a very bumpy curve that has bumpy and unpredictable impacts on our society.
And that's really something that climatology, climate science is just starting to appreciate, the importance of extreme events. If I rewind 2 years, there wasn't much discussion of the importance of extreme events. But again, climatology, we're finally appreciating how the changing frequency of heat waves, droughts, storms, that may be, or that seems to be the much more important issue, rather than this, as you say, this change in the average, this slow incremental warming. It is the heat waves and the storms that we need to be prepared for.
But isn't it also unfortunate, though, that a lot of these effects, these extreme events, are happening in geographical areas where the people can least afford this effect on their food supply? In fact, just a little bit earlier, we were talking about the effect of the cold on corn for Mexico, and they consume on average 90 kilograms of corn through tortillas every single year each, and it's a stable food, so they can least afford these kind of effects. Jason.
Right. It's people that are already having a marginal economic lifestyle. They don't need much of a push to become in a desperate economic situation, and so those of us in the relatively well-off countries, another storm or even a 10, 20, 30% change in our food prices is not going to lead us to riot in the streets. But certainly if you're already living on the margin, then that's more than enough to push you over.
Yes, that's right. It's the wealth that we have gives us what I think they call adaptive capacity. We have health systems, we have distribution systems and food systems that enable us to cope with adverse events in a way that a subsistence economy simply can't. Or even, as you said at the very beginning, an economy that isn't sort of interlinked into the rest of the world, which does give you some kind of cushion against bad events in your immediate locality.
Right. I think something like the Australian droughts 2008, the Russian heat wave 2010, that's happening on the other side of the planet. But now that we have a globalized economic system, commodity trading, those regional disturbances are felt globally.
Absolutely. Anyway, thank you for that. Now, let's move on to your specialist subject. This sounds like a quiz show. Jason, you've been working on Greenland for many, many years. How did you get started in all this?
I was at the University of Colorado. I was an eager 20-year-old who threw my name in the hat to join a Greenland climate research expedition. And after that first trip, I spent 60 days camping on the inland ice. I naively thought, well, that was a once-in-a-lifetime experience. And what took me one or two more trips to realize was this was the beginning of a career. And since the age of 20, I've committed to specializing on Greenland ice climate interactions. And this was in the mid-90s, and at a time just before ice sheets really started to grab headlines. I remember being taught that ice sheets took tens of thousands of years to react to climate, and so well, it was an exotic place to go, and I thought, well, that was interesting. But there are a number of epiphanies in the philosophy of science that I've been a part of, and it really started in the year 2002 when GPS measurements showed that there was a very fast reaction of ice sheet flow speed to meltwater production at the surface. And we saw these moulins, these crevices where water is falling down and lubricating the ice sheet flow, and we saw the water flowing into them, but somehow we needed the GPS measurements to confirm what was already known for 100 years in alpine glaciers, that they flow faster after a rainfall. And so the ice sheet, even though it's much larger, somehow the scientists couldn't appreciate that meltwater also produced a profound flow acceleration, 100% speed up in the summertime. And so that I've been part of that generation that has witnessed these profound philosophical advancements in climatology and glaciology. And to think that we don't know much today, it's true. There's much that we still don't understand, but in my short career, I've seen tremendous advancements in our understanding of the climate system.
Would it be fair to say though that that Greenland has been out of sight, out of mind? I mean, we get all these facts and figures coming back, but because no one lives there, or no one, there's hardly anyone there, that we don't really understand or grasp what's going on because it's not so real.
Well, what we say in response to that type of a question is that though the Arctic and the Antarctic are very sparsely populated, what happens up there is of great significance to the rest of us at the mid-latitudes in the tropics. So these remote areas do have profound connection to the mid-latitudes via global sea level rise and ocean circulation changes.
So when you go to Greenland, and you're off in a few weeks' time, what are the big changes that you noticed, personally, from when you were first going up there in the mid-90s?
I've seen enormous changes with my own eyes, and one example is each year we would fly over the world's most productive glacier. It produced more than 20 cubic kilometers of ice discharge into the ocean every year. This is the largest glacier outlet to the inland ice in Greenland. And I'd flown over this glacier on the way to Swiss Camp each year since 1994. And in the year 2003, we simply didn't recognize this glacier. The surface had become much more chaotic as it had doubled in flow speed. It had retreated at the front. It had lost an area more than the size of Manhattan Island, at the same time as doubling in speed. And we just thought we weren't looking at the same glacier. Oh, it must be the next one as we flew north. And so this was then in 2004, a major publication documented a very surprising doubling in speed of the world's most productive glacier. And I had seen that with my own eyes, and I had heard some of the old timers in my fields talk about how, they remember this glacier at this point in the valley, and now it's a couple kilometers up. But this was a 10-kilometer retreat of the world's most productive glacier. So it was a kind of an ominous and privileged experience to be able to witness that with my own eyes over the span of a decade. Since then, last year, for example, there was this enormous 4 times Manhattan Island Petermann Glacier detachment, the largest observed in Greenland. That occurred just last year in August, but this time we had anticipated that. And 1 year earlier, I had gone there and installed sensors all along Petermann Glacier, including time-lapse cameras. And we believe that we've captured at a high frame rate this unprecedented ice area detachment. And we have only to get up there. And we actually failed to get to the site last year, so I had to lose sleep all this past winter. And in about a month, I hope to be gathering these flashcards with these photos. And I think if the cameras operated, and we don't know that right now, but if they did, I think that we will be sharing with the world a sequence of images like nothing they've ever seen before. This would be 4 times Manhattan Island. This is 260 square kilometer ice plate floating away from the front of one of the widest outlets in Greenland.
Wow. So this could possibly be one of those key sort of cornerstone bits of footage that may just galvanize more people into action around the world.
It could be, and that was the idea of us putting cameras there, because, as you know, a photo is worth 1,000 words, and image sequences and time lapse of these kind of geologic events sped up in a way that you can just watch a glacier flowing as a very dynamic system that it is. We being able to share that is again a privilege. And I am very interested in people being aware of what the changes are in the far north because of their significance.
So you've been working with the Extreme Ice Survey, is that right?
That's correct. I was a founding member of EIS in Greenland in 2007, and we, together with James Baylog, the very talented photographer, we together installed the cameras in 2007, and then we have endeavored to keep the cameras running, and we now cover 10 outlet glaciers in Greenland at 30-minute intervals.
There are some amazing pictures on that EIS website. I'll put the link in the show notes, but it's worth keeping an eye on that site because the pictures are just stunning. Just stunning.
It's been very helpful.
When you were up at the Petermann, when you were up at the Petermann Glacier, I mean, it looked like a warm summer's day. The brilliant blue skies, the sea looked calm, the ice was white. It looked like the most stunning landscape.
It was like being in the Mediterranean. You know how if you've been to to Nice or someplace like that, it's the water's cool, it's blue skies, it's a dry, mild, sunny place. And the Arctic, it's a misconception that the Arctic is always cold. In the summertime, you have 24 hours sunlight, and in North Greenland, it is an arid climate, less precipitation than in the Mediterranean, and we also encountered this body of water between Greenland and Arctic Canada to be completely free of ice. This was unprecedented in ship navigation history. There had only been about 16 ships that have gone into this body of water that are known, and we were most fortunate that in terms of our navigation that the ice was being held out of the bay by a very anomalous ice conditions. Normally, this strait would be full of ice, but in recent years, the ice has been kept about 400 kilometers to the north, and made this site much more accessible.
So one of the key things about the Petermann Glacier, it's right up on the top northwest corner of Greenland, isn't it? It's about as far north as you can get. I know from some of the the coverage of the changes in Greenland, that the melt that began in the southwest seems to have been spreading up towards the northwest. This is something you see up there?
Yeah, for example, we have noted in the satellite measurements of sea surface temperatures a kind of a warming front that has propagated northward. This has been confirmed actually earlier in hydrographic surveys where they're actually dipping temperature sensors well into the ocean column, that there has been a northward pulse of warm subtropical waters. And these warm waters, an epiphany in the year 2008 was how ocean warming and a warm pulse of water can destabilize a massive glacier much more efficiently than a few degrees of atmospheric warming. We now appreciate that the climate change story is much more a story as told from the oceans than it is the atmosphere. Yes, the atmosphere is warming, but the big story here, I think, not just in cryosphere and destabilizing the ice sheets via ocean warming, the global climate change story, that the big story is ocean climate change, given that 7/10 of the planet is ocean covered.
Yeah, and my understanding is that something like 90% of the heat that's accumulating in the system is going into the oceans, and so, yeah, it's logical that will have an effect, particularly on ice. But the atmospheric conditions in Greenland have been astonishing, haven't they? You've done, I think, 7 successive years of the annual report on Greenland weather and climate for the BAMS. You better tell us this. The Bulletin of the American Meteorological Society, is that correct?
That's correct, and they endeavor to make an annual assessment of climate, and I am leading this report the last 7 years, as you said, and I solicit the science community and I ask them, do you have anything to add? This is what we have. And so it's an open process where we simply document what is interesting about this particular year, and then always in the context of past years. For example, has there been a warming trend and or a cooling trend, and the story has been one of increasing temperatures, and just this year 2010, we have the warmest year globally. We have the warmest year. I can see the graphic you have up. It illustrates some very long-term temperature records. That amber color, that's from Greenland's capital of Nuuk, and the 2010 calendar year temperatures are just going off the chart, and that is common with all of the West Greenland stations. What is shown in that graphic are 3 station records. The longest record is 160 years long, and then 2010. Part of a warming from the mid-80s, but then it's really shooting up in this anomalous year, the warmest year globally, the warmest year on record in Greenland. And this anomaly, this warmth is observed at all of nine West Greenland stations, and then that red dot in the southeast, that's a site where there's no runways, there's no heat sources. A well-known climate change skeptic, Anthony Watts, used the Nuuk record to say, what's up with this, spike in temperatures, and then he discredits the record, showing how there's an airport nearby, and it must be the airport that's causing global warming by warming up the temperature sensors.
It's got to be.
But I looked at all of the temperature records around Greenland, and especially that one in the southeast. There's no runway, there's no building nearby. It's on a skerry, which is just a rock pointing out of the ocean, and that's in the south. That's the red record. They all have this common spike in temperature. It's in a number of months, so it is a robust signal. And so, okay, what's going on? In short, it's a very strong circulation in the atmosphere, pumping heat from the south along West Greenland, and the Canadian Arctic as well is registering record-setting temperatures. And so 2010 is nothing less than a shocker of a year in terms of not just Greenland climate, but bear in mind it's the warmest and wettest year globally on record.
Yeah. Yes, that particular warmth over Western Greenland seems to have carried on through this Northern Hemisphere winter as well. I think we put in the show a couple of weeks ago about the incredible anomalies over northeastern Canada and Greenland. Whilst big blizzards are hitting the US, they've got kind of plus 20 Celsius degrees positive anomalies up there. Quite amazing.
Yeah, and very confusing to the public when they see a cold winter. They confuse weather and climate, and while the two are of course related, what's happened the past two winters, I think you mentioned in your show as well, it's been a pattern of very warm Arctic, like up to 20 degrees Celsius above normal in the Arctic. And that's flushing out cold air that's normally bottled up in the Arctic, and it's been flushing out over the continents, making everyone think that global warming is canceled, when indeed it's really a pattern of climate change, and a much more complex pattern that one has to think about very carefully. And so it has been frustrating to see how skeptics have very ignorantly used this cold weather as a means to discredit an enormous body of science about climate change.
Absolutely. The irony is that what might turn out to be the strongest signal of a changing climate might be the very thing that leads them to believe it isn't happening.
Yeah, it's a real paradox, and of course, people that are not spending their time on these issues full time. I can understand it. It can be very confusing. Very, I think ultimately people would like to believe that climate change is not human induced, because it removes the complicity in climate in an environmental catastrophe that we all play a part in, and so it's much easier to deny awful truths like this.
Now, I know it's not specifically your area, but when you're up there in Greenland, have you noticed effects on the wildlife or even the people that live there?
Most Greenlandic people, they quite honestly, they welcome climate warming because they have a long winter there, and one of the cultural patterns I've observed is decks being built on houses, and Greenlandic people, getting into barbecuing on their new patios, because the temperatures are
turning into Australians.
Fair. Yeah, it's fair weather in the summertime much of the time, and I think it is worth also acknowledging that while we are observing an abrupt climate warming that is very, if you look at the science objectively, it is caused by humans' activity largely. An equal amount of cooling would be probably a bigger problem. That is not to say that climate warming is not a problem. It's not to say climate warming is a good thing, because obviously it isn't. I mean, desertification and the threat that's not just the threat, but the problems that's causing with food security. That's a perfect example of why climate warming is not a good thing. But as much climate cooling would be a bigger problem.
What are your views on a tipping point, a point of runaway climate change or runaway effects on Greenland?
I think it's a great question because as Arctic climate warms about twice the rate as the rest of the globe, um, we are activating a tremendous carbon store in the permafrost, and that if a sufficient quantity of permafrost carbon is released to the atmosphere, we may well enter what we call runaway climate heating. The as there the positive feedback of climate warming, the reduction of a reflective snow cover and sea ice, that is underway, and as so this positive feedback is on, it's happening. It's not something off in the future. This is amplifying the warming in the Arctic. This has been the pattern very clear for decades, actually. It's only intensifying now further. Now, that is threatening this activation, this release of ancient stores of carbon from the permafrost. I consider that to be the most urgent problem in climate change, because if we let out even a small fraction of the terrestrial carbon from these peat bogs and tundra, then I think it's game over for life as we know it.
Yeah, it rips the reins out of our hands, doesn't it? It makes anything we do to reduce our own emissions completely irrelevant.
Yeah. So in terms of the question was about tipping points and thresholds. I believe that is a good example of the most urgent tipping point problem. If and what that threshold is, I don't think we know very well. I've asked some of the experts in the field, and I've been astonished to learn how little they how little they can really respond to that question. And these are supposed to be the experts. They say that it could be happening anytime. I think the problem. So it's a very kind of hot topic in climatology to understand. When is permafrost carbon coming out? And I think those observation programs have just begun. And I'm concerned that we may be once again surprised by how rapid climate change occurs, simply because we haven't factored in yet another climate sensitivity.
Yeah. Now, the other major factor, long-term factor, which has been, people have been revising the number upwards since the AR4, and that's the question of sea level rise. And obviously a major contributor to future sea level rise is the Greenland ice sheet as it melts. So we've heard people talking about anything from half a meter to 2 meters sea level rise by the end of the century. Given that you go to Greenland so regularly and that you're going to be there in a few weeks' time, what's your kind of educated gut feel on the future of the Greenland ice sheet?
Well, the projections for the end of this century, global sea level contributions between half a meter and 2 meters, that's still the conventional thought about the rather large envelope of the rather large range of possible global sea level rise values. My impression in that context is that in my own short career, I've witnessed a number of major surprises that have occurred. For example, the world's fastest glacier doubling in speed. Prior to that moment, there was no real no imagination to conceive that a glacier this big could possibly do that. There are a number of even wider outlets in Greenland that have not sped up yet. They are showing the preliminary signs of the what I call the awakening sleeping giants. The Humboldt Glacier, that's 110 kilometers wide. It's the widest outlet in the Arctic. This glacier is based below sea level, so it terminates in the sea. The bottom of this glacier is well below sea level, all the way into the deepest parts of the ice sheet, and it's likely to. It has been actually retreating its front at an accelerated rate. It's still well, I mean, last year it lost 30 square kilometers. That's a relatively small number for this glacier, but I anticipate what we'll see with Humboldt, Petermann, and a few other very large outlets in North Greenland is that they probably are going to be doubling, tripling in speed in the coming decades. I think so. If that happens, when that happens, I think it's more likely than not. If the types of changes that are actually ongoing in the Antarctic, West Antarctic ice sheet, again, this is a marine-based ice sheet, like much of North Greenland, we will see sea level contributions start to mount further. I mean, this isn't like it's something off in the future. It's actually already underway. If you look at sea level rise, it's just going like this. There's a retreat at the fronts of the key outlets in Antarctic ice sheet. An independent gravity survey from a satellite measurement is showing an accelerated mass loss from both Greenland and Antarctica. So this is actually an underway process, not off in the future. To cut to the chase of your question, Tad Pfeffer made a kind of an upper end possible calculation. What is the maximum possible that Greenland and all other glaciers on the planet could produce? And we're talking, those are the estimates that are above 1 meter. But to rule out 2 meters, we start to get into science fiction, because we don't actually have the knowledge about the dynamics of the systems, and therefore I think we shouldn't be surprised when we are surprised in the future.
And we'll try not to mention the day after tomorrow or anything like that in this context. Heaven forbid.
If you rewind back to 2002 when that film came out, and it was preposterous how quickly they portrayed this reorganization of Earth's climate, but even though they made this science fiction, what still seems preposterous, the concept of abrupt climate change, that we can have a massive reorganization of our climate in a matter of years, that is possible. I don't think we would see the kind of the instant ice age. In fact, the climate projections that do include the slowdown of the North Atlantic current, the Gulf Stream, there's a modest amount of cooling around Scotland, but overall the global climate system is still warming it. So the notion that all of this warming somehow leads to cooling is according to the science is actually false. It would lead to at most a relative cooling in the northern North Atlantic, a very limited area. Meanwhile, the rest of the planet continues to overheat.
Okay.
Yeah, it's fascinating. There's a graph in your draft for the BAMS paper. I don't know if Glenn can get it on screen. It's the Greenland ice mass anomaly deviation from average ice mass over 2002 to 2010. Now you have to go below that one, Glenn.
Moving down.
It's right down towards the bottom end of the paper.
All right, cruising down.
It's got an orange line running down. That's it. Whoa, back up. Now that's the gravity data you were talking about, Jason.
Right.
And, the orange line down that is a quadratic fit, isn't it? Which means it gets steeper as you go further along. And we're already talking about losing 1,200 gigatons of mass in 2010.
The annual loss rate in 2010 was roughly 300 gigatons. That's just under 1 millimeter global sea level rise for just that 1 year, just from Greenland. But you'll notice in the far right of the black line how it's really diving. That's the summer of 2010, in which we had an unprecedented melt. The acceleration term in that quadratic line is about 10 additional gigatons per year squared. And that's on top of this kind of trend of roughly 250 gigatons of mass budget deficit from the ice sheet. But to this number of like 300, the number 360 is equivalent to 1 millimeter of global sea level rise. And over 1 millimeter, that's pretty tiny, right? In 10 years, though, that's more than 1 inch of global sea level rise. And then when you include Antarctica, that's another inch. Then when you include the other glaciers and ice caps, yet another inch. So we're talking 3 inches per decade from global land ice. And as that, then thermal expansion is another 50%. We start to approach numbers that are of great concern to coastal planners, great concern to coastal property owners, great concern to maintaining infrastructure. That combined with storm surge, that can more than double these numbers. So to me, 1 millimeter per year sea level contribution from Greenland is becoming an alarming figure.
Yeah. Thanks for that. Well, perhaps no thanks for that. But fascinating to get your insights on that, Jason.
Don't kill the messenger.
We're trying not to.
No. Tell us where the messenger's going this year, because you've got a busy field season ahead of you, haven't you?
Well, I'm trying to keep it not too busy because I have a marriage to maintain, but I actually have a relatively short trip plan, and the purpose is to recover these photos from the Petermann Glacier. I set up 2 cameras last year. I think odds are we have pictures to pick up, and they again should show this unprecedented detachment of a very wide glacier in northern Greenland. In addition to that, we have some students that I'm supervising. This year they are leading themselves on a 700-kilometer snowmobile traverse across the Arctic Circle, across Greenland, where they're towing a radar and measuring it actually images down to 50 meters. And we will measure the snowfall rates across this line. And there are a number of other kind of related projects that I'm trying to just play more of a supporting role and get back to terra firma and publish as much of our findings as possible. I've got a tremendous backlog of I think very interesting publishable work. And I'm very grateful that I have a sabbatical right now, that I'm starting to make a bit of headway on the backlog of publishing. And besides my own, publishing goals, I look at others in the scientific community, in the climate science community, and I'm really impressed by the flood of more and more lucid information about the reality of climate change. And I suppose I'm equally disgusted by the obfuscation about these issues from special groups that are clearly representing polluting industries and then a political. And I can understand a group who's being paid by a petroleum company to try and block this, but someone who has an ideological problem with this, someone who, like I think you had Lord Monckton. He seems to actually be motivated not by profit, like many greedy people are, but he instead seems to be motivated by an ideological drive, which throws rational thinking out the window, and that is very frustrating.
It's a real kind of witch's brew of, the mixture of ideology and politics and fossil fuel money, and yeah, it's something that depresses me. But yeah, we have to do what we can, and the climate show is one way of doing it. And of course, Jason, by talking to us, you're helping to do it too, and your work is immensely valuable and immensely interesting. I should be watching Greenland from the satellites this summer to see if there's anything big happening up at the Petermann from the MODIS Rapid Response Arctic Mosaic, which is a fantastic picture. And of course, we'll be monitoring your blog, meltfactor.org, which I hope you'll post to regularly and keep us up to date with everything that's going on. And I can promise you that the minute you release the pictures from the Petermann from last summer, we'll have them up here on the Climate Show. So many thanks for taking the time to talk to me.
Yeah, and hopefully we'll be able to catch up with you on the other side of the what is very sobering work, but also very exciting work, I think, as well. And I can see how you can be really excited about going up there to Greenland. So maybe we'll catch up with you on the other side of that.
Yeah, you guys keep doing this great show. I think this is a wonderful service to people, and I think you guys are doing great. So thanks for having me on.
Thanks, Jason.
Thanks, Jason. That's great.
Well, fantastic to chat with Jason Box, and really looking forward to hearing about his stories once he comes back from Greenland, Gareth.
Yes, I want to see those pictures of the Petermann ice breakup. I really hope that those cameras kept working.
Yeah, indeed.
Should be a fantastic sight.
And so don't forget, all the show notes are at the new website, theclimateshow.com, and feel free to join in the conversation over there. Don't forget also to follow the Twitter stream for The Climate Show, twitter.com/The Climate Show, and facebook.com/The Climate Show as well.
And I'm trying to persuade Glenn to experiment with Audio Boo, which is a kind of Twitter sort of podcasty type thing, which we might do as a little bit of a sort of intro to the show. But anyway, Glenn, I've committed you to it.
You have now. So what do you think? We'll send out a wee sort of preview of the show before it goes out, because while I'm still editing it together.
Yeah, just a couple of minutes, to let people know what's going on.
Okay. Yeah, that sounds good. All right, we'll make sure we do that.
And now it's time for John Cook, Skeptical Science Supremo.
Indeed. G'day there, John.
G'day, Glenn. Hey, Gareth.
Hi. Now, John, this will come as some surprise to you, I'm sure, but we've just been talking to Jason Box about Greenland, and he tells us that the Greenlanders are turning into Australians because they're all building decks on their houses and starting to barbecue in the summer. So...
Is that true?
and similar to us, they're probably getting washed towards the ocean like we were over the last month.
Yeah, maybe. So this week we're going to talk about common myths about ice.
Yeah, I started telling all the ice myths on my site, and we've got quite a few actually. So I just narrowed it down to like the half dozen top arguments.
All right.
Okay, well, run us through them.
Okay, all right. Well, firstly, just to sort of set the tone, all of them, except for one, all these arguments have one thing in common, and that's that they just focus on one little piece of data or a single paper or just a tiny part of the puzzle and ignoring the rest of the evidence. So now a common argument that you hear is that Greenland is gaining ice, or it's getting thicker in the middle. And I've seen photos of like some hut in Greenland or a measuring station or something, which is just slowly getting buried by ice. And the implication is that Greenland's gaining ice, so we don't have to worry about Greenland contributing to sea level rise or anything like that.
But as we've just been hearing from Jason, the reality is quite different, right?
Exactly. What that's doing is just looking at what's happening in the middle of Greenland, which is what we expect as it gets warmer. There's more precipitation and it builds up, snow and ice in the middle. But around the edges, the ice is falling faster and faster into the ocean. And so the overall picture in Greenland is that it's losing ice, and it's losing it at a faster and faster rate over time. So this graph here is just it's a gravity measurements, which just looks at the entire ice sheet over Greenland all in one go, and it's found that the rate of ice loss has doubled over the last decade or so.
Wow.
Yeah, Jason told us that the 2010 melt season, enough ice melted on Greenland to raise a global sea level by 1 millimeter, which is incredible.
I think on that graph you can see that it lost about 600 billion tons of ice mass over the 2010 summer, which is the most it's ever lost in a single summer. And to give you an idea of how much that is, in Australia we'd probably just say that's equivalent to about a single Sydney harbour.
Wow. Yeah.
Because that's how we measure everything.
Yeah, of course. That or beer cans or something.
Yeah, I haven't done the beer conversion. I'll have to do that next time.
A lot.
How many Eskies of 6X? Yes.
4x, yeah.
Cool. All right. So is that are we just debunking that one ice myth this time?
No, I've only just got started.
All right,
So,
let's get into it. Come on.
Okay, so the next one is a Himalaya Gate, and that was a pretty. In fact, it's still quite popular, where there was an error in the IPCC's fourth assessment report, so where the IPCC said that by 2035 the Himalayan glaciers would disappear, and this was wrong. This was an error, and it's helpful to find out how that came about, because the actual figure disappearing by 2035, that came from a report by the World Wildlife Fund, and then when you track where they got it from, they just got it from a news item in the New Scientist. So it didn't come from a peer-reviewed study. It was just kind of a series of non-peer-reviewed sources.
What was New Scientist doing with non-peer-reviewed stuff? Do they do that often?
Well, New Scientist isn't a peer-reviewed journal. It's more like a science news. So they were just I think reporting like an interview with a scientist who threw out that figure.
I've lost a little bit of faith in New Scientist magazine.
Well, they're a popular science magazine, and I used to work as a journalist on weekly magazines, and I can tell you it's a real kind of treadmill that you're on, having to get a magazine out every week. And yeah, you make mistakes, they slip through. It's you just have to catch and correct them. And New Scientist generally is quite good about picking up its mistakes and correcting them.
Okay, you were saying.
Yeah, like the moral of the story is that the safe, the most reliable source of information for science and climate science is peer-reviewed papers, and that's what the critics of the IPCC were saying. They were saying, why shouldn't the IPCC should have been using peer review as their source, not a WWF report. And that's actually a good thing. That it's good to see that climate skeptics hold peer review in such high regard. But unfortunately, they weren't really practicing what they preach, because none of them seemed to be looking at what the peer-reviewed science was saying about Himalayan glaciers. And what they were finding was that satellites measuring what's happening over the Himalayas found that like 80% of glaciers in Western China had retreated over the last 50 years, and that the retreat was accelerating across most of Tibet. So yeah, so even though the 2035 figure was incorrect, the signs, the measurements we were getting from the Himalayas are still pretty concerning. And the graph I'm showing here is actually our global glaciers, like just all the glaciers that we're measuring across the globe, shows that just as in the Himalayas, also globally, the amount of glacial retreat is accelerating. And
what's the reference on the vertical axis there of the graph?
I wish you hadn't asked that. It's this really opaque little figure. It's like means to specific mass balance, which is basically just a measure of how much mass the glaciers have.
Okay.
Yeah, it can be quite complex. There are all sorts of numbers they use, but the big picture is absolutely clear. And then this is one that annoys me every time I see it. This claim that somehow, because one number is bigger than another, that somehow the Arctic sea ice has recovered.
Yeah, there was a big kerfuffle just over the last few weeks where there was an astronaut, Harrison Schmitt, he used to be an astronaut. I think he was a senator for a while, But he published a paper saying that Arctic sea ice had returned to 1989 levels. So basically saying Arctic sea ice is back to normal. It's all recovered. It's all fine. And when scientists started looking at the actual numbers of Arctic sea ice in 1989 and comparing it to 2009 when Harris and Schmidt wrote his paper, what we found was, well, there was actually a lot less sea ice in 2009. So what was he talking about? And the Heartland Institute defended his statement by saying in April 2009, this Arctic sea ice was actually, just over 1989 levels in April 1989. But that's a classic cherry pick, because when you look at the values of Arctic sea ice over those 2 years, the red is 2009, and you can see that Arctic sea ice is well below 1989 levels, all except for that one little spot where it pops over, in April. So obviously that's the spot that the Heartland Institute focus on, while ignoring all the rest of the evidence.
Like that big change down there in the dip as well.
And if you look at the graph below that John's provided, the change in Arctic ice volume, that gives you an even better picture. That you go back to 1989 and you look where the ice volume was then, and look where it is in 2009. It's a huge difference.
Yeah, I mean, it's important to realise that coverage or sea ice extent is just looking at what sea ice is happening, on the surface. It's like a two-dimensional picture. But more important is the total amount of sea ice or sea ice volume, and that the Arctic sea ice has just been shrinking and getting thinner and thinner over the last few decades. So that like this graph here showing that sea ice volume, or the total amount of sea ice, has been diminishing sharply, and it's at record low levels in the last couple of years.
Okay, what about Antarctica then?
Okay, so you often hear people say, well, Antarctica is gaining ice, and the first thing to realize with Antarctica is that there's two types of ice that is often talked about: land ice and sea ice, and they're two separate phenomena. So often people will talk about Antarctica gaining ice, and they confuse the two different types of ice. So firstly, let's look at land ice. Now that has actually been falling down at an accelerating rate. So just with Greenland, the ice sheets are sliding faster and faster into the oceans, and particularly in West Antarctica, where it's losing most of its ice. But overall, when you add up West Antarctica and East Antarctica, overall it's losing ice mass, and it's at a faster and faster rate. So, but the interesting thing about Antarctica is the sea ice around the continent has actually been slightly increasing over the last couple of decades. And the question that skeptics never seem to ask is why. Like whenever I read a blog post where they talk about Antarctic sea ice going up, the general assumption is that it must be because it's cooling around Antarctica. But the Southern Ocean, where the sea ice forms, is actually warming, and it's warming faster than the rest of the world's oceans. So I think I might have given you a picture of what's if you look at the Southern Ocean around Antarctica, it's actually warming quite strongly. So this is a really interesting question. Why is Antarctic sea ice rising when the oceans are warming around there? And unfortunately, that question seems to get lost when Antarctic sea ice is used as a blunt instrument in the Boxsters. And so there seems to be several contributing factors, and this is still an area of research. One of them is the ozone hole over the South Pole. What that creates is cyclonic winds around Antarctica, and those winds push the sea ice around, creating these areas of open water. And when you've got open water, that allows more sea ice to form. And then another factor is that it's been snowing more around Antarctica, and that's another prediction from warming temperatures. And the snow acts like an insulator, which preserves sea ice. So it's quite a complicated and interesting, question, what's happening around Antarctica.
The other thing, of course, is that skeptics will often try and pretend that, yes, okay, there's the Arctic is losing ice, but Antarctica is gaining ice, and I think Moncton says there's a sort of natural balance being struck, but that's just not the case, is it?
Yes, this was my last ice argument, and all the previous arguments, they all kind of cherry picked, or just looked at one little bit of the data and ignored the other evidence. But this argument is just plain wrong, saying that the Arctic sea ice is equal to the gain in Antarctic.
Would be convenient if it was, right?
Yeah. So, but if you actually look at the trends in Arctic sea ice, the drop in Arctic sea ice is 3 times greater than the gain in Antarctic sea ice. So globally, sea ice has been dropping over the last few decades.
And of course certainly has been this Antarctic sea ice gain, because we see it floating past New Zealand sometimes.
Actually, the stuff that goes floating past New Zealand is probably the remains of a big berg from one of the glaciers or an ice shelf, because sea ice is quite thin.
Oh.
Wouldn't last long enough to get up here.
Interesting.
Anyway, thank you for that, John. That's most interesting. What are we going to cover next time, do you think? What's hot?
I'll just bring up my list of arguments, close my eyes and point and see what I come up with.
That's how it's done.
Okay, well, let us know, and we'll look forward to talking to you again. Many, many thanks.
Okay, see you guys.
Cool.
Cheers, John.
Cheers, John. That is John Cook over at skepticalscience.com. That's where you go and head, and of course also the show notes will be up at theclimateshow.com. Now, I hope you're still with us, because we're into the final home stretch now. It is the solutions, the many-part solutions segment of the show, where we look at some of the green tech. And in this episode, an optimistic report by WWF.
Yeah, they've got released a report a week or so ago, the energy report. They claim that we can meet all of our energy needs in 2050 by using 100% renewable energy. And that's quite a big claim, because most people accept that other fuels, fossil fuels, nuclear energy and so on, are going to have a significant part to play, at least in some sort of transition. But what WWF have done is they've used a major energy consultancy called Ecofis, and they have constructed a scenario which moves the world towards being able to produce all of its energy requirements from basically wind, all forms of solar, and geothermal. It leaves just a little bit of fossil energy running. And of course hydropower. So you put all those, and tidal power, ocean power. So you put all those things together with smart grids, so that the energy is being distributed really effectively, with a huge amount of investment in energy efficiency, so that we're not wasting energy, and that the energy we generate and use is used effectively. And they've come up with a scenario that allows them to power the world with 100% renewable. And really, the bottom line on that is that there's enough energy arriving at the planet from the sun to meet all of human civilization's energy needs many, many, many times over. So capturing enough of it to run our society should be doable. It's not doable at the moment, and it will require technology improvements, but it's going to have to be doable in the future, because one, fossil fuels are, certainly oil is limited availability in future. Certainly there isn't going to be as much oil, and I think that what you're showing on screen there is that if everyone consumed as much energy as the average Singaporean and US resident, we'd use up all the world's oil reserves in 9 years. Yeah. So, there's not a lot to go around, and so we're going to have to find alternatives, and those alternatives are going to have to be low carbon. Now, I know that there will be many people who'd argue that nuclear has got a big part to play in this, because it is a very efficient producer of large amounts of effectively zero carbon, after you've built the nuclear power stations, that is, zero carbon power. So I would say that probably the WDF report is an interesting and a valuable contribution. It's not necessarily the answer all on its own, but what it should do is give us some encouragement that if we're smart about this, we can move towards 100% renewable energy. And certainly most of our investments from here on in should be going in energy that we know can be low and zero carbon.
It is all very encouraging and nice and everything, but it does feel like fairies down the end of the garden, though. This report, to me, I mean, it assumes a lot of things. It assumes a cooperation around the world and people to be good-natured and to be sharing and to help each other out.
Yeah, absolutely. And it also assumes the heroic assumptions about how efficiently we can use energy. That doesn't mean that I think they're not feasible.
Yeah.
But are they likely? That's completely another matter. Yeah. And I mean, you've got to stack up about that. That while oil is running out, oil companies are going to make a vast amount of money because the price for their product is going to continue rising. It's a great time to invest in oil companies because they're going to continue to make record profits, because it's going to take a long time to wean our system off oil. But at the same time, those oil companies are actually actively lobbying for us to do nothing about carbon.
That's right.
And that's not a clever move.
The future's lignite, Gareth. Haven't you heard? Lignite.
Oh, please don't.
That's what we should be doing, lignite.
Oh, every time somebody mentions Southland lignite, coal fuel plants, I feel like banging my head on a table. But perhaps I should bang Don Elder, the head of Solid Energy's head, on the table instead. That might be more productive.
Lignite to me always sounds like something sci-fi. Actually, it sounds like something that you would dig out of comets in order to keep your starship going. That's what it is. Lignite.
No, unfortunately, lignite is very low energy. It's brown coal. It's the lowest.
It's the bottom of the barrel.
Lowest usable.
Yeah,
you might as well be cutting peat to burn in your bothy,
Okay, well,
anyway.
Finally on to our last story.
Yes, now this is one for hairdressers everywhere, and it's a fantastic news from Porsche. Porsche have already begun to build hybrid versions of many of their cars. There's a hybrid Cayenne, but they're building their first all-electric car, and this is an electric Boxster. And I think the figure is it'll go from 0 to 60 miles per hour in 5.3 seconds. It's got 2 electric motors, one for the front and rear axles. They're only building 3, I think. So they're a kind of proof of concept. But they're going to be running them around Germany and around their labs in Stuttgart to test out. But it's a clear sign that Porsche are looking to an all-electric future. And for those who lust after sports cars, at the moment their only option is the Tesla, which is actually it's a car based on a British design, the Lotus LEs, built in the States with an electric drivetrain. Been very successful, costs about $100,000. No doubt the Porsche will cost something similar, but people buy Porsches because they love them.
No doubt it'll become the car of choice for Silicon Valley entrepreneurs.
Yeah, absolutely. I'm sure you'll see hundreds of them in California eventually. But the tactic is interesting because it's making EVs, electric vehicles, sexy.
Yeah.
And if you can start convincing people who are into petrol heads to be electron heads instead, then maybe we'll get more of a trickle down. And also interesting, I think I may have mentioned a show or two ago, but the Chevy Volt, which was their plug-in hybrid, actually won Car of the Year in America. So encouraging signs, I think.
Would you prefer to be seen in the Datsun or the Porsche? Both electric.
I think that Datsun would see the Porsche off, wouldn't it? might be a bit embarrassing for Ferdinand Porsche and his team.
Indeed, it could be. All right. Well, you can get all the notes for the show up at theclimateshow.com. Episode number 7, of course, this is.
Don't forget,
and
we'll be posting it at Hot Topic.
Exactly, Hot Topic as well. And of course on Facebook you can always sign up to or like the show up there, facebook.com/Radio Whammo, and do tweet us and share
Absolutely.
the show if you like as well on Twitter, twitter.com/The Climate Show as well. And
As much feedback as possible, please.
yeah,
Provided you're not rude about us.
yeah.
I think there was. What was that comment that we were all stuttering fools or something?
Mumbling, something else. Yeah,
Yeah, well, whoever wrote that could just fade away.
Indeed, and of course, do subscribe to the show. However you like it. Either subscribe on YouTube or on iTunes or your favourite music player as well. And all those links, as you'll see, are up in the show notes as well. That's been another great one.
Well,
Thanks to Jason for coming on board.
Yeah, no, that was great. I really enjoyed that interview, and I'm plotting to get another star guest with some luck for our next show. And my fingers are crossed, but hopefully that'll be a good show too. So, looking forward to it, Glenn. That was another good one, and we'll be recording again in 2 weeks.
We'll see you in 2 weeks. Thanks. Cheers, Gareth.
Cheers.
What good is a drop in the ocean? What good is a drop in the ocean?